All right, so today, guys, we're continuing with some more examples about how to analyze motion of a particle. So you're given this function, 80 times e to the negative t over 10 minus 40t meters. Okay, that is the position equation. So now we want to take that and write its corresponding velocity and acceleration equations. Okay, so this gives us the position, and that's in meters. And now what we want to do is calculate what's the velocity. Okay, so we know we're going to take the derivative of the position in order to get the velocity. Okay, all right, so we got to do our derivative here. Okay, the derivative of 80 times e to the negative t over 10. All right, now when we're doing the derivative of this, you could be using your product rule. Okay, so you got the derivative of 80, which is now we got to do the derivative of negative t over 10, e to the negative t over 10. Okay, so if this was u and this was v, okay, the derivative of this, e to the negative t divided by 10. All right, so if you remember back when we did our derivative rules, okay, the derivative of e is itself times the derivative of whatever the exponent was. So when I do the derivative of this, it's going to equal e to the negative t over 10 times, okay, what's the derivative of negative t over 10? That's what you're doing next here. So we've done that part, e to the negative 10 t over 10. Now you got to do the derivative of negative t over 10. What's that equal to? Negative t over 10 is the same as negative 1/10 times t. What's the derivative of that? Yeah, negative 1/10. Okay, so the derivative of the exponent is negative 1 over 10. Okay, this is the derivative of negative 10 over t. Excuse me, it's the derivative of negative t over 10. All right, so the derivative of this term is e negative, or 1 over 10 times e to the negative t over 10. Okay, and then you cross multiply and add up the products. So this times 0 is gone, and now your derivative would end up being 80 times 1/10 Okay, did I lose a negative? Yeah, that's negative 1/10. E to the negative t over 10. So that would equal negative 8 e negative t divided by 10 plus 40. Or minus 40, and that's meters per second. All right, now that's our velocity. Now we got to get our acceleration, which is the derivative of the velocity. Okay, so now you're doing the derivative of this term. So it's going to be just like this, except for 80, you're going to have negative 8. Okay, so when I do the derivative of that, if I follow my rules, negative 8, its derivative is 0. Okay, the derivative of e to the negative t over 10, okay, we already know is negative 1/10 e to the negative t over 10. And then I do my cross multiplying. Okay, plus negative 8 times negative 10 is positive 8/10 e to the negative t over 10. Okay, so this part is going to be, let's see, I can reduce that to 4 over 5 e negative t over 10. Okay, so here's our velocity function. Here's our acceleration function. All right, grab a calculator so we can do our initial positions and stuff. Okay. So we got S is 0, V is 0, A is 0. Okay, Zach, you find S is 0. All right, Mickey, you calculate V is 0. Jesse, you calculate A is 0. Okay, so as this term right here gets bigger and bigger, what does that y value approach? So what you can do just to see that is put that into your calculator. So go y equals And I just want to see what happens to this as x gets bigger and bigger and bigger. So I'm going to type in E. And this then is going to be negative x divided by 10. Okay, now graph it. And what does the right tail approach? Okay, so here's the right tail all the way over here. As t gets bigger and bigger, what does the y value of this graph do? It approaches 0. Okay, now if I wanted to see it in a table, I can go second table set, take the independent and change it to ask. Second table set. Take the independent and change it to ask. Then go second table, and you can type in the values. So like at t is 100, the number is 4.5 times 10 to the negative fifth. Okay, so that's 0.0000045. This number is very close to 0. Okay, if I made that x 1,000, that's 4 times 10 to the negative 44. Okay, so that's 4 with 43 zeros in front of it. That's a really small number. So, as you guys said, this term approaches 0. All right, so what happens is, as t gets really, really big, 8's going to end up getting multiplied by a number that's really close to 0. Subtract negative 40. And my velocity is going to end up approaching negative 40 meters per second. Okay, now what does that mean in terms of movement, Balin? Which way is it moving and how fast? Okay. Right. So, to answer this question, as t approaches infinity, the velocity approaches negative 40 meters per second. Okay, the particle is moving left at 40 meters per second. So if we were to graph this function, if we were going to graph, this is the time and this is the velocity, okay, the graph is going to approach negative 40 on the y-axis. So this is negative 40 meters per second. Okay, so here's the graph of that. Okay, and as you can see, okay, there's 0 all the way up there. So as time goes up, as time goes out to infinity, this graph approaches negative 40 from below and levels off at negative 40. So it'll get really close to negative 40, but never reach it. So our graph is going to end up looking like this. Negative 8e to the negative 10 t over 10 minus 40. So I just put that into Desmos and graphed it. Okay, now the next part is, what's the velocity? When is the velocity negative 44? Okay, so we could get an estimate of that using our graph. Okay, so we want to know at what time on this graph is the velocity about negative 44. So when I put a point on this graph, okay, what does the coordinates of this point tell me right now? What do those numbers mean, Jesse? Okay, so the point 0, negative 48, which is the y-intercept. Okay, say that again. What's it telling us about? Right, yep, so that's your initial velocity. All right, and now we want to know, well, when's that velocity going to be negative 44? Okay, so if you look at your graph here, I want to know when is the y-coordinate negative 44? So somewhere in there. Now, if I want to know exactly, what second equation would I type in and look for the intersection? Negative 44. When I type that in, now this intersection is exactly when the time, or it gives me the time when the velocity is at negative 44. Okay, so when we solve this, we'll end up with at 6.931 seconds, 6.931 seconds. Let me put it on here. I'm going to put it on this graph because we're going to need space to solve it down here. Okay, at 6.931 seconds, the velocity is negative 44 meters per second. So we solved it graphically. Okay, now we want to solve it analytically. Okay, so we know we should be getting something. Our graph tells us 6.9 seconds, roughly. All right, how do we solve it? What equation do we set up to solve it analytically? How do we find when the velocity is negative 44? Yep. So what you're going to do is you're going to set v of t equal to negative 44. And then you're going to solve that resulting equation. All right, so let's do that. So over here, I'm going to take, here's v of t equals, okay, negative over 10 minus 40. And now I'm going to take out via t and put in negative 44. Okay, now we got to solve that. So what would we do? Yeah, add 40 to both sides. So that's going to give us negative 4 equals negative 8 e negative t over 10. Okay, now what? Divide by negative 8. So I'm going to get 1/2 equals e to the negative t over 10. Okay, now that's an exponential equation. E negative t over 10. Okay, now how do you solve an equation where you have the variable in the exponent? Did it last year. Yep. So to get the variable out of the exponent, we're going to do the log of each side. Since we're dealing with e, we're going to do the natural log of each side. Okay, so we're going to take the natural log of each side. So I'm going to have natural log 1 divided by 2 equals the natural log of e to the negative t over 10. Okay, now what? There's a way that we could rewrite this. Yeah, so we called it the basketball rule or the power rule. We're allowed to take that variable, that exponent, and move it out front. So now this becomes the same as negative t over 10 natural log of e. Okay, and the natural log of e is what? ln e. Yeah, it's 1. So this part essentially just becomes 1. So the right side of this is now negative t over 10. We've solved it. We've gotten t out of the exponent. Okay, now I got to do the natural log of 1/2. Okay, so let's see, ln 1/2. All right, so I'm going to do the natural log of 1/2. ln 1 divided by 2. And I get negative 0.693 to 3 sig figs. Negative 0.693 Okay, now multiply both sides by negative 10. And I get positive t equals 6.93 seconds, which is what we got when we solved it using Desmos.